Welcome to homework.
Given an equation in which you're told the amount of product that forms, actually, you can calculate what's called the percent yield, which describes sort of how effective the equation was. So in this equation, we have two quantities of reactants, salicylic acid and acetic anhydride. And we know that we produce 3.281 grams of aspirin. This is called the actual yield. To figure out that what's called the theoretical yield, or how much we should produce, we have to convert each of our masses to moles. And we do that using the molar mass, which we find from the periodic table by adding up the individual molar masses of each element. Once we have moles of our reactant, we can find moles of product. And we do that using the mole ratio from the balanced equation. Once we have moles of product, we can find grams of product. And again, we use the molar mass. We can complete the same calculation with the acetic anhydride. The only difference is that since we're given volume, we first have to find mass. And we do that using the given density. And then we can change it to moles of the reactant and then moles of the product. And then finally, grams of product. The calculations will give two different final masses, and so whichever one is the smaller amount of product is the amount that should form. And again, this is called the theoretical yield. So before we start the conversions, the molar masses of each of the substances that we look at. If I have C7, H6O3 has a molar mass of 7 times 12.011 plus 6 times 1.008 plus 3 times 15.999, all found on the periodic table, or 138.122 grams per mole. The molar mass of acetic anhydride is found similarly to be 102.089 grams per mole. And finally, the molar mass of aspirin is 180.159 grams per mole. So we use our starting masses. Starting with the salicylic acid. Change it to moles by dividing by the molar mass. Multiplying by the coefficients from the balanced equation, which in this case, it's a 1-to-1 ratio. And then multiplying by the molar mass of aspirin. So this mass would produce 4.260 grams of product. If we do the same calculation, given our other quantity of acetic anhydride, CH3CO2O, we start off with a volume. So we have to first multiply by the density. And then change to moles. And then using the mole ratio, which again is 1:1. And then finally multiplying by the molar mass of aspirin. This gives us 10.5 grams. So we can see that the limiting reagent is salicylic acid, and the amount that should be produced at theoretical yield is 4.260 grams. So our percent yield is how much we did produce, or 3.281 grams, divided by how much we should have produced, 4.260 grams, times 100, or 75%. Another way to look at the efficiency of a chemical reaction is something called the atom economy. And this is a percentage that looks at the mass of each atom in the desired product which in this case is aspirin, divided by the mass of each atom in all of the reactants. Or in this case, our reactants are C7H6O3 and CH3CO2O. So to find our atom economy, we simply look up the atomic mass of each element and multiply it by the coefficient, by the subscript in the equation. So it'll be 9 times 12.011 plus 8 times 1.008 for hydrogen plus 4 times 15.999 for oxygen. And then divided by, on the bottom, we can combine the total numbers of atoms. So there are 11 carbons total. 12 hydrogen, and 6 oxygens. And this gives us an atom economy of 75%.